Hello guys, this is Vishant. So welcome to your channel, which is Sci Engineers. In this particular video, we're going to discuss on engineering mechanics topic, which is going to be friction. If you're new to the channel, we have been already making videos for the first year of engineering, first semester. So you can go and check out those videos which we have done for your basic electrical engineering, for your engineering mechanics, and also for the applied mathematics sections. So in this section we are going to discuss about friction, which is the topic in engineering mechanics. So do hit the like button, do share it with your friends, and if you're new to the channel, please do subscribe to our channel and hit the bell icon just present beside the subscribe button to never miss a notification of the videos which we upload. So let's get going. So let us understand some concepts which are related to friction. You might have already done with this topic in your earlier standards. So friction is nothing but the force which is going to be opposing to any sort of motion. Friction is such type of a force that it should be avoided as much as possible, but it is also needed for our day-to-day life. It is always a necessity while walking, it is always a necessity while driving a car safely, it is always necessary for keeping a system in stationary motion. It is required in many ways, and it is also not required and hazardous in some of the cases. So let us try to understand this particular friction, which is helping us and also being a disadvantage to us. So to understand friction, the basic definition of friction is it is nothing but the force which opposes motion. It is always going to be opposite to the direction of the motion in which the body is moving. So let us try to understand the laws of friction by taking an example of a weight which is kept on a surface. So let the weight of this particular block be W. It will be having an equal and opposite reaction in the opposite direction from the surface. Now if we consider that there is a pull of P in this particular direction on this weight, if the surface is smooth, then it will be quite easily moving as soon as the force is applied to it. But if the surface is not smooth, then in that case we have to consider some force which is called as friction. So friction arises because the surfaces are not smooth in nature. If you go for the microscopical analysis of the surface or the point of contact of this thing, you might observe something like this. The surface which is present over here will be actually something like this, and the block which is kept on that particular surface will be having some structure like this. So you can see that there is an interlink between them, and because of the interlink present between the block and the surface, there is some force which is called as friction which is generated. The friction which is going to be there, it is always going to be in opposition to the force which is going to try to make it move. So you can see that this particular force is trying to move this block in the right direction. So your frictional force will be opposite to that. So that will be in the left direction. The point of application of the friction is always at the point of contact of the surfaces. So let us try to understand some of the laws which are related to friction. The first main law is that it does not depend on the area of contact of the surface. So it basically means that it does not depend on whether the surface of the body in contact is going to be huge or small. The amount of friction which is going to be generated, it's always going to be same. The next law for friction is that my frictional force will be always proportional to the normal reaction. So you can see that in this case, this particular reaction which is from the surface towards the block is the normal reaction. So it is always going to be equal to the normal reaction. So your frictional force is going to be directly proportional to your normal reaction. To remove the proportionality sign, you have to use something which is called as frictional constant. So now what you're going to do is you are going to plot this particular graph in which you are changing your applied force and you are calculating the corresponding frictional force generated. So what you will see, as it increases, your frictional force is also increasing with your applied force. But this frictional force is going to be limited for certain amount of force only. After a certain point, it's going to have a decrease in its frictional force and it's going to remain constant. This particular point at which it's going to stop increasing is called as a limiting frictional force. So this particular point is going to be used for our analysis of equilibrium in many of the sums which we are going to see. So this value is going to be equal to the maximum frictional value which is going to be generated, which is going to be equal to your mu into your n. And this particular value, that is for which it's going to be remaining constant, it is nothing but the kinematic friction which is being generated. So for this value, your F is going to be, your F kinematic is going to be mu k into n. So you can see that after a certain point, there is going to be a drop in the maximum friction which is going to be generated between two surfaces, and it will be constant at this particular value, that is mu k into n, where n remains the same, that is the normal reaction which is being generated by the surface, where mu k is nothing but the coefficient of kinetic friction and mu s is the coefficient of static friction. So from this, what do you understand is that there is going to be a maximum limiting value of friction which is going to be applied or generated by a particular surface, beyond which the frictional force drops, and there will be a constant kinetic friction which is going to be generated henceforth, which is going to be of constant value. So to understand the concept which we have just seen, let us consider this example. I have a block A which is going to be of weight 2000 newtons. It is kept on an inclined plane of 35 degrees, and there is a wire which is being attached to it from a pulley. We are given that the pulley has negligible friction between it, and it is attached on the other end with a weight B. I have to find the minimum amount of weight which will be required to make this block A just move. So in this particular problem, the thing which is given to us is that the weight A has to just move from its position, and we have to find what is the amount of weight B should be having. So for this, you have to understand, since it is given that A should just move from its position, that means that A should be applied with a force that is going to be equal to the maximum frictional force that is going to be generated. That we know that it is going to be equal to 0.2, that is your mu into the normal reaction which is going to be generated by the surface. So for that, what you need to do is you need to understand the FBD of this particular block. So let us try the FBD of A. So A is inclined on this particular surface which is at an angle of 35 degrees. Then we have to understand that since it is lying on this surface, so it's going to have a normal reaction which is going to be perpendicular to the surface. It's going to have a weight which is going to be downwards. So you have to understand that this way is going to be the weight of A. Then it is attached to a string, so there will be a tension T which is going to be generated over here. And since we want A to move in the upward direction, the frictional force is going to oppose the motion of this. So your F, that is the frictional force, should be in this downward direction. Now since your frictional force is to be maximum, this value should be equal to mu into n. So now what we need to do is we need to solve the condition for equilibrium. So for equilibrium, we are going to consider the x and y coordinate system. So what you can see is that most of the forces are lying on this particular axis. So we will be considering this as my x axis, this as my y axis. So considering this particular axis, it helps me to write the equation in that coordinate system. So we need to find the angles of the other remaining forces, because this already is in the x direction, your normal reaction is already in the y direction. The only two forces which are not in those coordinate systems are going to be your weight and the tension T. The tension T, which is already given to me, it's making a 20 degrees with the surface, so it's going to have a 20 degrees over here. To find your WA, what you need to understand is the geometry which is present. So what you can see is that this particular is 35. If I just draw this particular triangle, I'll be getting this as 90 degrees. This particular angle is going to be 90 minus 35. And since this is perpendicular to this surface, so this particular angle is going to be basically 35 degrees. So basically what you can see is that engineering mechanics is all about the geometry of angles and triangles. So you have already determined all the angles for the different forces. Now you need to write their corresponding equation. So since we are solving for equilibrium, your conditions are going to be summation fx equals 0 and summation fy is equal to 0. So let us first concentrate on summation fx. So you have to consider that you have taken this axis, that is the plane which is going to be parallel to the surface, is x axis. So now you have to consider only the components of the forces along the x axis. You can see that T is making an angle of 20 degrees with the x axis. So it's going to have a T cos 20. Since it is going in the positive direction of x axis, it's going to have a plus sign. You can see that your maximum frictional force in this case is going downwards, like in the opposite direction to the positive x. So it's going to have a minus mu n. Then you can see that the weight is making an angle of 35 with the y axis. So you have to take the sine component for it. So it will be also a minus WA sine 35, which is equal to 0. So rewriting the equation, substituting the known values. So you will be having this as T cos 20 minus, you have the mu value, that is 0.2 n, is equal to, you have the WA value, that is equal to 2000 sine 35. So this becomes your equation 1. So you can see that there are two variables to be found out. So you require two equations for it. So the next equation will be your summation Fy. So considering your summation Fy is equal to 0, so you will be having your, first of all, the normal reaction to this surface which is going in the positive y axis. So you will be having a plus n. Then you have to consider the component of T along your y axis. So that's going to be a plus T sine 20. So that's your sine component for the tension. Then you will be having the component of your weight. So again it's minus WA. It's going to be now a cos component for it. So cos 35. This thing is going to be equal to 0. So you are having, rewriting this equation. So that's going to be 2000 cos 35. So this becomes your equation 2. Solving 1 and 2, you will be getting the values of N and T. So you're getting the values of tension and your normal reaction. You have to understand that the tensions and normal reactions are such types of forces which are never going to have the value negative. So if you are getting the value as negative in such types of sums, then something is gone wrong in your writing the equations of it. So you can just keep this thing in mind. Now the next thing what you need to find is basically the weight, that is the weight of this particular block. So you have to consider the FBD of B. So if you consider the FBD of B, it's going to be quite simple. So this is your B. It's going to have the weight which is going downwards, and there is a tension T. So you can see that since this is a smooth surface of the pulley, whatever is tension which is generated in this direction will be same as that is generated in this direction. So because of that, the tension which is going to be present at this particular point for B is also going to be the same tension that is which is over here. So what you can see is there are only two forces which are basically opposite to each other. So if you take directly your summation Fy in this case, which is equal to 0, you will be getting your Wb is equal to T. So your Wb is equal to T, that means your Wb, that is the weight of B, should be 1380.39 newtons. So this is what you need to find out in this particular sum. Let us take one more type of a problem in this to get the concepts clarified. So let us consider this problem which is given to me. We again have a block A which is kept on an inclined surface. We have been given that the weight of A block is 1000 newtons. So the question which is asked to me is that if for A I am applying a horizontal force which is 1200 newtons, so what will be the conditions of A? That means that whether A is going to be in equilibrium condition, or if it is going to slide downwards, or if it is going to go upwards. So for this we have to make certain assumptions. So what we will do is we will start drawing the FBD of A. So we will consider the block A which is kept at an incline, that is at 30 degrees. It will obviously have a normal reaction which is going to be perpendicular to the surface. It's going to have the weight downwards. So this is your WA. Then it will have the frictional force which is going to be opposite to the motion. So first of all, let us show the force which is being applied. So since it is horizontal force, so it's going to be like this. It's going to be 1200 newtons in this way. And now what we have to do is we have to consider the frictional force. Now frictional force is obviously considered opposite to the motion. But we don't know whether A is going to be moving upwards, or whether it is going to move downwards, or whether it is going to be in equilibrium condition. So in this case what we have to do is we have to make some assumption. So let us assume that my A is moving upwards. So if A is to move upwards, that means that the frictional force should be downwards. So let us consider this as my F. But I still don't know whether the frictional force, whether it's going to move, or is it going to be at just an equilibrium, or what is the condition applied over here. So in this case I cannot take this F as the maximum frictional force. So I have to keep it as F only, and I have to check the value of F which I will be getting. So now there is no more forces which are going to be applied to it. So we have to just take the components. So again we will be considering the axis as this way only. We will be considering the plane which is parallel to the surface as X, and one which is going to be perpendicular to the surface as Y. Then we have to find the angles which it is making. So since it is given that this is 30 degrees, so by parallel lines property this particular thing will be 30 degrees. Then again you can draw this particular angle. This is going to be 90. This is 30, so this will be 90 minus 30. And since again it's perpendicular, so this angle is going to be basically 30 degrees. So now you have all the forces, angle with the corresponding axis. So you have to apply the condition for equilibrium. So in this case we are assuming that it's going to be in equilibrium. So we will have summation Fx equals 0. So summation Fx equals 0. So what we will be getting is, along the x-axis there is this F which is going negative F. There is the component for this particular thing which is going to be positive 1200 cos 30, and for the weight it's going to be minus, the weight is 1000, So it's going to be 1000 sine 30, which is equal to 0. So from this you will be getting the value of f. Then going for the summation fy equals 0. So for summation fy equals 0, you will be getting the value of n. So that's going to be n, which is going in the positive direction of y-axis. Then these two forces are going, the component of it along the y are going in the negative direction. So both of them will be negative. So that's going to be minus 1200 sine 30 and minus 1000 cos 30. So from this you will be getting your value of n. So what you can see is from this you are getting your f as 539.23 and your normal reaction. So from this what you understand is the direction of frictional force what you had taken is actually right. So basically your block is either moving upwards or it is stationary at that point. Now to check whether it's going to be moving upwards or is it stationary, what you have to understand is you have to calculate the maximum frictional force which is going to be generated by the surface. So for that you need to check your F max value. So you know that F max value is given by mu into n. You have already found out your n, which is 1466. So you have to just multiply with mu. So that's going to be 0.3 into 1466. So your F max value is coming out to be 439.8 newtons. What you can see is that the F max which is generated for this particular normal reaction which we are getting over here is quite less than that which is required for the equilibrium condition. So basically it means that the block A is going to move in the upward direction with some velocity. So these are some of the questions which are asked in this particular chapter, which is friction. We will be seeing more types of problems related to this chapter in the upcoming videos. So for that you need to subscribe to our channel, hit the bell icon to never miss a notification from us. Also do hit the like button and do share it with your friends so that it helps them in their studies also. So we are associated with Samartha Vidya classes for engineering and science students. We conduct classes for the BE, BTech and the Diploma level students. We also conduct classes for the 11th and 12th batches, for the PCMB and for the vocational students. Our classes are based in Mulund and Thane. So for inquiry, you can visit our Facebook page or you can email us at samarthavidya@gmail.com. So this is Sushant signing off. So keep learning, keep watching and happy learning. Bye.